What's happened this year is, as you probably know, 7 or 8 years ago, we did something that some people thought was stupid, some people thought was courageous. We said, we're deeply involved in cell phone handsets and other consumer products, and we don't see a happy ending for us there. The quicker we make a change and get back to doing what we've done for 20 years successfully, which is the hard stuff, use our better engineering, use our better processes and all the silicon it takes, but stop designing silicon circuits that fit on a tiny piece of silicon but are only worth 50 cents, and go back to making the hard stuff that's worth $2, $3, $4. So we directed the sales team to not focus on that business anymore, but more important, we told the design team, you got to go off and start doing what you used to do. That turned out to be a 3, 4, 5 year activity. The customs we're after now, also like automotive, 2, 3, 4, 5 year design cycle. So I think maybe the one message this year that I think is the message, and it's the message of our annual report. 7 years ago, management put the company in the right markets, took them out of the wrong markets, and our design team generated the right products. Okay, so this year we can celebrate right markets, right products, and right results. I mean, in order for us to make up for the business that we were going to walk away from in consumer, we said we're going to re-energize industrial, which is always big, and that has gone from the low 30s to 43% of our business as the top line's been growing. Automotive was 3 or 4% of our business when we made this decision. Now it's 20%. I thought maybe 20% was the top. Now I'm convinced 20% is not the top. In the communications area, we said that we want to hold our position here. Now, communications to most people means cell phones. No cell phone handsets, but we're still very strong in networking. We still have a role in base station infrastructure and so forth. So you look at those, 90% of our business is non-consumer. We still have some military business that's steady at 6-7%. We still have computer business at more than 10%. So we've found in all these markets, where we can play at this kind of level. But the markets that we're going to make up for the consumer business that's gone from 28% to 3% was more industrial and a big move in automotive. So our automotive business has been the fastest growing, but here's even better. It's almost like we're clairvoyant. When the analog market was 20 billion in size in total, automotive and industrial made up 20% of that. Fast forward to where we are today, the market is now over 40 billion, and industrial and automotive are now 43% of the 40 billion. So we're in the right place. We're in the right place at the right time, and I think we have a 5+ year head start in our competition. Even when our Electronica booth was as big as the telephone booth, it was always crowded. In fact, I dreamed about having a booth this big when I first came here 20 years ago, and now we have it. And I thought when the booth is big, maybe it won't be crowded, but you can see the booth gets bigger, the crowds get bigger. Our goal was to be the best and never was be the biggest. So our strategy was always be better before we're bigger. And I think that kind of strategy and a lot of good execution has created a company with great financial results. We have a chance to set the price when we are a sole source supplier. We don't sell things to a customer for $5 that's only worth $4. We sell things to customers for $5 that are worth $6. Okay, and so that's been our strategy from day one as well. Well, there's a challenge there. You have to be creative, and you have to be in the right markets at the right time, and you have to have the right solutions. And if you do, and you're first to market, then you can sell customers a product priced at a functional value. Okay, here's a functional value. This does your job. It's cheaper than what you're paying now, so everybody's happy. Maybe the thing that people give me credit for is deeply involved in the strategy, not the product strategy so much as the market strategy, but also the culture of engineering-driven culture. We're a company of engineers. We want to keep politics to zero. We want to keep bureaucracy. I'd like to say zero, but as you get bigger, there's bureaucracy snakes in. But if you can control those two things and make engineers, all of them understand that top management knows we're an engineering company. Don't second guess them on the engineering stuff. Let them go do it. We have engineers who want to do the hard stuff, so let them go do it. And sometimes we have to be patient, which isn't one of my virtues, but that's part of the secret sauce. I never forget we got to take care of the engineers, because that's what we're about. Hopefully that kind of culture, hopefully it's those kinds of things that have created the company that, quote, nobody leaves except to retire.
Hi, my name is Mike Mays, and I'm a design engineer from Linear Technology, and today I'm demonstrating the LTC2983. This is a device that directly measures the temperature of thermocouples, RTDs, thermistors, and diodes. It basically provides all of the excitation currents, measurement techniques, algorithms to directly measure these sensors, and then in the back end it converts the output from these sensors directly to degrees C. Combined with its real ease of use, it also is extremely accurate. For example, here I have a precision calibrator that's driving negative 200 degrees C simulated RTD into our LTC2983 device. And the LTC2983 is reading very precisely within 0.03 of a degree this reading. The part is also very flexible. It includes all the coefficients for standard devices, but it also can be programmed for any type of custom sensor, whether it's a custom RTD or a custom thermocouple. This demonstration is showing an extreme case where we have a custom thermocouple we made with a barbed wire and a copper. We characterized its voltage temperature properties, and we store it in the device. It can now directly measure the temperature of this device and output the results in degrees C.
We are here to present you the latest release of LTC's backup regulator part. It's the LTC3350. The block diagram is shown here. So what the part is capable of, it regulates main power flow, just dropping in the input, and the output is following the input. And with additional power, which is not needed by the output, this supercap reservoir is charged via this buck regulator with a constant current charge algorithm. And in case the input power goes away, this buck regulator gets bidirectional and works as a boost regulator, which uses the energy stored in the supercap, or battery if you like, and is then fed via the boost regulator to the output. And as you can see, it's a controller with external feds. The 3350 is capable of doing a lot of power. We're talking about 40, 50 watts of backup power, which was not possible with the parts anyone had before, which are integrated. And you see this slide diagram here. The normal application, the red one, is the input voltage. It goes away, and the output stays constant and stable because the energy of the cap is discharged with the boost regulator. And what we have here on our showcase, that we have just two light bulbs as indicator for the input voltage. The second light bulb indicates the output voltage. And when I now switch off the input net, the supercaps have been charged by the PCB with the 3350 on it. You see that the light is still running. It's not so bright as before because we have chosen 6 volt as a hold-up voltage, but this can be adjusted digital by the part itself or manually with feedback resistors. That means we can go shortly to the software, which is possible with this part, as it has an I2C interface. That means we go to the configuration and we would choose the backup voltage and store this value to the part. And when we go back to the graphical show up, don't get annoyed by the spikes. It's the software's prototype status. And I go back to the light bulbs. Now we should see that the light bulb, the output voltage, stays the same brightness as we have 12 volt over here. That means the green one was the input voltage going down. The blue one is the output voltage that stays constant, and the red one indicates the voltage on the supercap reservoir, which is discharged slowly by the light bulb. And when it's done finally, it cannot hold longer, the supercaps are discharged, the part shuts off completely. And with this part we have a lot of additional feature because it offers a balancing of the supercaps. We offer a kind of health monitoring because the part can measure the capacitance of the supercaps as well as the ESR. So the user has always the control of the health status of the energy reservoir and can see if it's necessary to exchange them or that everything is running fine with this application. And with this part, I think we have a really capable solution to offer backup power, which is really higher to supply system loads, which are talking about 30 to 50 watts, for example.
So this is the show of our power system management solutions that including a 4-channel PM bus power system manager where you can get accurate input current and energy measurement as well. You can sequence, you can trim, you can margin your power supply on your devices. The LTC2975 is a 4-channel device and you can drive 4 different power supply devices. And the LTM4675 is a micro-module dual 13 amps that you can parallel up to 26 amps as a micro-module regulator. And on this device there's on board the PM bus power supply system management. And you can manage all the output voltage level, you can manage your current protection, you can manage sequencing, you can manage the switching frequency on the device, and you are interfaced with the E2C and PM bus. This device and this demo is a fully demo where we include a battery charger that is driven by a hand crank just to provide a real accurate measurement of the energy that we are producing. For example, we can read the energy produced in 20 seconds, and we can read the power that is produced by 4 LED drivers that are on the main board. And in the meanwhile, we can control and read all the power that is used by our micro-module evaluation board, where we can provide up to 120 amps on 1 volt output. That is a really powerful solution, and you can manage everything by a PM bus, and you can have under your control all the status of your power system. So you can read voltage, current, energy, power, temperature, and you can read it by a graphic user interface that is really easy to use, where you have under control on over your devices that is inside your system. You can manage by this graphic user interface the sequencing, you can manage margining, you can shut down and turn on your system with different sequencing and different timing, and you can manage everything on your system related to the power supply. And now we have a customer that is trying to use the device to charge our battery and to let us know. Please wait your start sign. Go. Please, please let the light get more blue or maybe green.
Green is better than blinks.
Hey, come on.
Okay, so you produce 88 joule, and now let's see another customer. Ready to go? Let's wait to finish the publishing. Okay. In the meanwhile, you can see that we have the LED blinking. This customer is really powerful.